Welcome. My name is Ben Jackson. I'm a professor in the School of Forestry and Natural Resources at the University of Georgia. Today we're going to be talking about using Web Soil Survey for forestry applications or as a planning tool for landowners and others. This video is going to build on a video previously prepared using Web Soil Survey to determine road construction suitability. It focuses on using the program to determine proper culvert sizing for stream crossings. The first thing we want to do is return to the Area of Interest tab in the upper left-hand corner of the Web Soil Survey image. The next thing we want to do is by the photo where you've identified the area of interest, we want to click on Legend, and the Layers property menu will appear. Scroll to the bottom of that menu under Background and you'll see Aerial Photography checked. Please check the topography map and the next image will appear. This is our area of interest now identified on a topography map instead of an aerial photo. It's 100 Phoenix Road in Clark County. Several things you need to notice about that. The most important are the dark contour lines, as they call those, and they represent 100-foot intervals. So in this particular case, this contour line is 700 feet, and the one to the left here is 650 feet. Between that, those two dark lines are light gray, or they appear greenish in this image, or 20-foot interval contour lines. So there are 5 20-foot contour lines between 650 and 700 feet. Of course, that image is going to change as you move from one section of the country to the other. I provided a close-up here to show the dark contour line, 650 and 700 feet, and then the 20-foot interval contour lines between those. What we're interested in for this example is to build the possibility of building a road across this particular stream. You can see that this dotted line is an existing road system that has already been built, and there is a stream crossing there, and we want to determine in part as to whether or not that stream crossing or the culvert size is large enough to accommodate this particular stream, which in this case is an intermittent stream, meaning it doesn't necessarily flow all of the time, but it has a significant flow rate. And during storm events and other events, we need to make sure that the capacity of the culvert is large enough to accommodate the flow of water through that stream. All right, now we're going to use this image at 1/6000 scale, as you can see here, like we did in the previous example, to determine the size of the watershed that's going to be drained by this creek at this particular point. The way that works, again, is we go back to the polygon tool, and we start use our cursor, and we'll use this as a point of beginning here at 710 feet. You can see this is a light gray line indicating it's a little higher than it is at 700 feet here. So we go to the middle of that area, and we start tracing our watershed as the water flows down the hill to this 700-foot interval. and it goes down into somewhere around 690 something feet, back up to a slight incline here at 700 feet. So we go to approximately the middle of that. And then we start tracing down the contour lines to 690, 680, 670, 660, and finally 650 feet. It'll continue on down to 640, 630, and about approximately 620. So the low elevation here is 620 feet. And then we start going back up to 640, 660, 650, 660, 70, 80, 90, and back up to this large area here at 700 feet. And then we trace back to the beginning, back to the approximately where the road is, and then we close the polygon back to this particular point. For those of you that are not familiar with how to delineate a watershed on a topography map, I encourage you to visit the URL shown here, and it gives you a really good tutorial about how to trace out size of a watershed on a topography map. Once we finish with our tracing of the watershed using the topography map here, this is the image that you'll see. In this particular case, it follows fairly closely to the existing road that exists there on that watershed. The only big difference here is this section as far as the current road goes. So it's a little bit, this road section a little bit out of the watershed, but this area right in here is the size of the watershed. This is a close-up of the cross-hatched area after you've identified the polygon around the watershed, and it lets you know what you're looking at here in terms of acreage. If you wanted to transfer back to looking at that watershed in the aerial photo, this is what that image might look like. If you want to change the image to a hard copy, you can do that as previously identified in the other exercise. And finally, what we have here is we've identified the size of this watershed at 68 acres. So how do you determine what the size of the culvert should be, assuming you're going to put a culvert in at that stream crossing, or if you're going to examine whether that culvert you have in place is sufficient in size? One option is to use Talbert's formula. An example of that formula in use can be found at this URL. It's very simple. What we do in this particular case is we plug in 68 acres. The coefficient we usually use for forestry applications is 0.6. This is generally determined by the modified universal soil loss equation. It's a pretty standard practice to do that. And the results you wind up with is the size of the culvert that needs to be put in place. In this particular case is 54 inches. If you're in Georgia and you happen to refer to the Forestry BMP manual, or Best Management Practices manual for water quality purposes, if you went to table 3C, you can see in this particular watershed the nearest interval we have is greater than 50 acres but less than 100 acres, and what they're recommending is that you use a 54-inch diameter culvert, which is exactly the same as the results we got from the Talbot formula. Alright, this concludes the introduction to using web soil survey to determine watershed size and culvert sizing. I hope it was a valuable experience for you.